a pedigree. Remember, in this pedigree, you have different styles. A question can come when this pedigree is sex-linked. It can come when this pedigree is non-sex linked. So you have to take note of the following before you answer any question concerning about a pedigree. It can be sex linked, it can be non-sex linked, it can be caused by a dominant allele, or it can be caused by a recessive allele. So when you are trying to answer these questions, you have to first know this pedigree is caused by what? Is it a recessive allele? Is it a non-recessive allele, meaning that it's a dominant allele? Because if it is a dominant allele, then definitely you have to use the capital letters. If it is a recessive allele, then it means that you're supposed to use small letters. So please take note of that. Then, if it is saying that, if the question comes and is saying that it is sex linked, if it is not saying that sex linked, please don't use X and Y. So we're going to look at these questions. We have different kinds of questions we're going to look at, so that at least you don't suffer with this. Kundai is saying that I received a distinction. Thank you very much for receiving a distinction, and I know that at the end of the year you will receive distinctions. I always say that distinction times 2. All right, the first question is saying that these are national examination questions, like obtained from the past papers. Please always and always use these past papers so that they can guide you. All right, the first question is saying that moya is a disorder caused by a dominant allele. Moya is a disorder caused by a dominant allele, capital R. You see, the question is stating it that it is caused by a dominant allele. This disorder damages the arteries supplying the blood to the brain. Okay. So that is what is important here in this statement. We don't want to know supplying the blood. We don't want to know the condition. What is important is caused by a dominant allele. This is a key point. As I say that it can be caused by a recessive allele. It can be caused by a dominant allele. It can be sex linked, or it can be a non-sex linked, meaning that it is an autosomal character. So please take note of that. So in this case, first of all, it is caused by a dominant allele, and they are saying that they are not specifying anything here. They are not saying anything here that it is caused by sex linked. However much I've talked about male or female, I should not use X and Y. So let's go. The first question is saying that how many generations are represented in the diagram? When you talk about generations here, you only have to look at this is the first generation, this is the second generation, this is the third generation. So in other words, there are 3 generations which are indicated in this diagram. So the answer here should be 3. And then they're saying that give the letter, sometimes letters of an affected male. Now, sometimes we give you a key, which means you have to take note of it and then know that whether it is caused by a dominant, caused by a dominant allele, recessive allele, but we don't give you a key to show that this is a male is affected, this is a female is not affected. So we just give you the question. So please take note of that. So in this case, they gave you a key. So the one we shaded is affected with the disorder. The one who is not shaded is not affected. So it means that you have to take note of that. So in this case, we are saying that affected male, a box. We say that a box means a male, and then a circle means a female. So if they're saying that an affected male, so here they're saying a box which is not shaded is unaffected. So they are saying that, so I come here and I find out it's only one person who is unaffected. So the answer is saying is supposed to be H. I think that's why it is also 1 mark. Then they are saying that genotype of individual A. Where is genotype of individual A? So because this is someone who is affected, yes, and this is not, they have not said that this is a sex linked. And then number 2, they produced a kid who is a female, and this kid is not affected. So what does it mean? It means that if this kid is not affected, it means that this person is recessive, small r. And then this one is not affected because this is caused by a dominant allele. So it can either be capital R, small r, or capital R, this individual A. So, but because this is small r, yes, and then they produce a kid who is small r, yes, it means that one allele came from the mother. Obvious, mother is like that, as we have seen it here, and one allele came from the father. Therefore, the father can't be this. So the father is like that, meaning that one allele came from the father, one allele came from the mother, and they gave rise to this kid. Hence, A is of this genotype. So it is A is heterozygous. I think I'm clear there. Yes. Then the next question, they are saying that genotype genotype of A, we are done with that. It is capital R, small r. Give the letter or letters. Can you please start? I just logged. I just logged in. Yes, we are going on. We are going on. Yes, so if you have just missed it out, yeah, don't forget that we have a lot of questions down there. So try to keep up, and then you'll get there. So we are saying that give the letters of what? Of let me check here. Someone is disturbing me. All right. Give the letters of individual who is not biological uh, uh, kids for A and B. Where is A and B? A and B. A and B. So in this case, this line means they gave rise to these two kids. This person C, and this person F. It shows that they just got married. You see, they just got married. So F and C are not biological children for this. So it means that the answer here is going to be F, yes, this F and C, because this, if this line was like this, then they would have been this the kids of these parents. But because this line is not like that, it means that, what does it mean? It means that they just got married. So this is not a biological child for these two, and also this is not a biological child for these two. So I think I'm clear there. Then they're saying that, uh, they're saying that, sorry, they're saying that brown enamel, this is another question. It's another question. Brown enamel of teeth is sex. Now here, this question, they have specified that this is a sex linked. So in the question, if they don't specify that this is a sex-linked disorder, please do not talk about X and Y. However, you see now here, we have not talked about X and Y. So please find out whether it is caused by recessive allele, dominant allele, sex-linked, autosomes, meaning that non-sex-linked. So there is another question here. This question is about pedigree again. But this pedigree, what are they saying? One type of defect in human is carried on single allele. Okay. The diagram shows the inheritance of deafness in family. So they are not specific that they are not saying that this is caused by is sex linked. No, they are not saying that. So if it is not showing you that is caused by sex linked, then automatically I have to keep it the way it is. Yeah, it means that you are not supposed to 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 check to use X and Y. Yes, you are not supposed to use X and Y. Just a moment. Okay, it's locked. All right. They are saying that how many generations? We have seen this question before. How many generations is one generation? This is the first generation. First generation. This is the second generation, and this is the third generation. So this pedigree diagram showing three generation. Children of Paul. How many children of Paul and Liz? This is Paul. This is Paul, and this is Liz. So the answer is gonna be 1, 2, 3. Yes, this is not a child of Paul and Liz. Why? Because this is just married. This means interbreeding or sex is happening, or marriage or cross, whatever you can describe it. And then yes, so it means that there are three individuals. So also it is 3. Then they're saying which phenotype is dominant? Which phenotype is dominant? Based on this, you have deafness and then a person who can hear, deaf and hearing. You have to, since they didn't show you that this is dominant, this is recessive, you have to look at maybe 2 parents and then their kids, and then you see which one leads to the other. So if you look at this and this, this will not show you because we don't know whether it's heterozygous, or even this one will not show you, but this one can show you. This is showing this person is hearing, this person is hearing. But they produced a kid who is deaf. What does it mean? It means that these two, they had a recessive allele for deafness. It means that deafness is caused by recessive allele. Therefore, hearing is caused by a dominant allele. So, which phenotype? So the answer here must be hearing. Hearing. Yes. And then use the offsprings of Bob and Anna. Oh, Bob and Anna. So it's the same thing we have used. We use the same example. Why are you saying that hearing is the dominant allele? As I said that Bob and Anna, yes, use Bob and Anna to explain your answer. Bob and Anna, yes, look. We are seeing that Bob and Anna, both of them, if this is Bob and this is Anna, or Anne, whatever, yes, if these two are normal and they intermarried or interbreed and they produced this kid, and this boy who is deaf. What does it mean? It means that this person, if it is small r, they are recessive. It means that Bob had is capital R, small r. Even this one is capital R, small r. And then this came from the mother, this came from the father, and then they joined, and then they formed this kid who is, let me show you. A kid who is having the disease. It means that this allele, and this allele, they came here. Yes. So it means that, so use Bob and Anna and explain your answer. So you can say that Bob, who is a male and is hearing, yes, married, yes, Anna, who is female and is hearing. Did they say it's caused by sex linked? No. So that's why you're not saying anything with X and Y. So this Bob, who is hearing, meaning that Bob is capital R, small r, is heterozygous. In other words, heterozygous. Don't use small r, because they didn't give you the letters to use. Bob is heterozygous, and also Anna is heterozygous. They passed their recessive allele. Even Anna is like this. They passed their recessive alleles to one kid, and the kid became deaf, which is small r, small r. So that is the reason why Bob and Anna produced a kid who is having this defect of deafness. I think I'm clear. So sometimes they try to change it, tilt it, as long as you know the principle. How do you identify? Please look at the babies. Ne? If you see the babies, you'll see them that if one person is sick or is affected by the condition, it means that the parents are heterozygous. You understand? If the two parents are normal, it means that the two parents are heterozygous. But if all of them are normal, then it automatically shows that the parents are homozygous, dominant. Use letters A to represent a dominant allele and small a recessive allele. Show recessive allele to give all the possible genotypes for hearing individual. Possible. Use capital dominant allele and letter A for recessive allele to give all the possible genotypes for people who are hearing. It's 2 marks. Remember, we said it here. A person who is hearing, yes, and remember, hearing is dominant. If it is capital R, say this, capital A is for hearing, ne? And then small a is for deaf. Yes, it means that a person who is hearing can be homozygous, like this, homozygous dominant, or can be heterozygous. This person is hearing, and also this person is hearing. So these are the two options you can give. So we will give you a tick here and also give you a tick there. The last questions. I have this question, and then I have another question and another question. So yeah, basically I have 1, 2, 3 questions to smash. Okay, let's smash these questions together. All right. They're saying that this question is now pedigree, but now this pedigree is sex linked. Is sex linked. You remember the question we saw? It was not pedigree, but it was sex linked. But now this one is pedigree and is sex linked. So we are bringing sex linked character in the pedigree. This syndrome, however, I don't know how you're gonna, whether it's hotty or gotty or whatever you read it because it's an scientific term, but I know that many students read it as hood. Okay, is sex-linked genetic disorder? It is caused by a dominant allele. You see, it's caused by a dominant allele on X chromosome. This shows that this is a sex. I told you that you cannot use X and Y unless it's mentioned in the question. Yes. Or they're gonna ask you, is it sex-linked or non-sex linked? The diagram below shows the inheritance of this syndrome in the family. Okay, name the type of uh, diagram represented above. We have been talking about it. Is a pedigree. Is a pedigree. Pedigree diagram. This is RNA. How many female are in this family? How many female are in this family? Remember, circle means a female. Yes, it's one, it's two, it's three. What about this? This one is not a member. It just came to get married. Get married. Ne? But they're saying how many female? Okay. It's one, it's two. Since now they are going down, they're saying females, not kids. Yeah. Okay. It's one, it's two, it's three, it's four, it's five, it's six. Yeah. Yeah. They're not saying kids, they're saying uh, all the females. So there are six females. Males in F1 generation. F1 generation. They're saying F1 generation. How many males in the first generation? So remember, you have first generation, second generation, then third generation. So how many generations are these? There are three. So they're saying how many males in the generation? So it's only one, the father. Yes. Then they're saying that the next question, they are saying that uh, give Gabby's genotype. Who is Gabby? Ne? Who is Gabby? Gabby's genotype. Where is Gabby now? Oh, Gabby. Is it caused by dominant allele? Yes, it's caused by a dominant allele. So if it is caused by a dominant allele, so what does it mean? It means that when you are writing it, yes, you're supposed to 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 shaded means affected with age because whoever is where is Gabby? Yes, this person is affected with this disorder and is caused by the. So it means that you have two options. Either you have Gabby is a female, so it can be capital G, small g, or it can be capital G, capital G, capital G. Yes. So, but the question is saying they give Gabby's genotype. So, which of the two is correct? Now you look at the babies. Is there any baby who is normal without the condition? Yes. Is this. And remember, this is the recessive allele. So it means that this is a male with small g, capital Y. And this is a female, small b, small g, small g. So it means that if this individual, this individual, if this individual is this one, if this one is a female, small g, ne? And then this one is a male, small g, and then y. So the father is already the father. This one, yes, the father is already having small g, capital Y. Automatically, how did this individual and this individual get this recessive allele? if the mother is like this. Therefore, automatically the mother can't be this, so the mother is that, like that. So it means that this Gabi is, so the answer is gonna be X capital G, X small g, so that it shows that the individual is affected because of this capital G, but has a recessive allele which is being transferred to the offsprings, so that the offsprings are free from the condition. And then they're saying that we are done with that. They're saying that Anju and Pilusa have 4 children. Give the phenotype of their sons. They want to know the phenotype of their sons, Anju and Pelusa, because they're saying sons. Okay. The sons. Okay. So now look. Pelusa is a male. Yes. Pelusa is a male. And this Pelusa is what? Is affected. So meaning that is having a capital G and a capital Y. But Anju is a female. Anju is what? Anju is a female, of which is caused by a recessive allele. You see, this is Anju. No. This is Pelusa. Pilusa. And then Anju is a female, meaning that it has no effect. And remember, it is recessive. So if they are looking for the sons, so how are these sons going to be? Automatically the son is going to have this. You know why? It's because the father will always give the come from there, will always give the y to the son, and then the x is always coming from the mother. So the disease or whatever recessive conditions in males, if it is sex linked, is caused by the female. Why? Because the father is always giving the Y chromosome. So this came from the mother. And then since it is recessive, so the person is unaffected. So the description here, you're gonna say that, and for children, give the phenotype of their. So the answer is gonna be unaffected male, or unaffected, or these guys without Hortis syndrome. Yes. Explain your answer. So it's the same thing. This question is similar to the question we tried to attempt before. Explain your answer. Why are you saying that they're going to be like this? They're going to be unaffected. So you can say that Pilusa is affected. Yes, you see that Pilusa, we have seen it that Pilusa is affected. Yes, is a dominant allele. Yes. Well, Angie is unaffected. You can say unaffected, or you can write this. Yes. Males inherit the Y chromosome, as I've talked about, that males inherit the Y chromosome from Pelusa. You see, these boys, the sons, they inherit the Y chromosome from Pelusa, and then they inherited this X with the recessive allele from Anju, and this Anju is already affected. Hence, the individual is going to be like that. So, how do I get the 4 marks? 4 marks by telling us what's happening to Pelusa and what's happening to Anju. Pelusa is affected, a tick, while Anju is unaffected. Yes. So the boys or the males will inherit the Y chromosome from the father. Give you another tick, yes, and then they will inherit the X with the recessive allele from the mother. That's all. Yes. You see, genetics is simple, but if you are not keen, it might crush you down. So you must always think before you try to answer questions concerning about this genetics. Please don't just rush and then you answer these questions. No, the questions you have to read them, you read them, you read them, you read them, you read them.